Hi, I'm Scott Gerben, Crane Application Engineer for Siemens Industry USA. This is the third in a series of videos introducing SIMOCRANE basic technology V5.0 for the SINAMICS S120 platform. This video will cover some hoist-specific functions such as TorqueProving, StartPulse, and Simplified Load-Dependent Field Weakening, or SLDFW for short. We'll start with the TorqueProving block, which can be used to prove proper function of an inverter before brakes are opened and the speed set point is output. For each new master switch command, a torque set point will be given to the drive. If the torque set point from the drive exceeds the saved torque value, the brakes will be allowed to open and the drive will be given a speed set point. If the actual torque generated by the drive is not capable of exceeding the saved torque value, the brakes will not open and the target torque not reached block output will be set high. Taking a look at the TorqueProving block diagram, you can see the main block inputs and outputs. The enabled TorqueProving input on the TorqueProving block is directly interconnected to the main drive block. So you will use the main drive block EN TorqueProving input to enable and disable the TorqueProving function. You can set a minimum torque value that defines a minimum torque that must be checked every time a new master switch command is given to the drive. You can also set up the torque ramp up time, torque reached mon time, and the delay time torque save inputs. However, default values are recommended for these parameters until the drive is commissioned. Please note that when TorqueProving is used, StartPulse from the LCRBT DCC library can't be used because both blocks are using the same speed controller interface of the drive. This trace displays a successful master switch command where the TorqueProving block has been properly set up. It shows two separate operator commands being given to a drive with TorqueProving activated. In both movement commands, the drive responds to the operator input by ramping the drive torque set point up to the target torque value, which also happens to be the saved torque value for both of the movements. Once the drive is able to reach the target torque value, the brake close command output is set to 0, allowing the hoist to move only after the target torque value has been proven. Once the operator command is complete, the brake close command is set back to 1, the brake is closed, and the torque set point of the drive returns to 0 until a new operator command is given and this process is repeated. During script setup of this block, you will start by parameterizing the Boolean input that enables the TorqueProving block at EN TorqueProving within the main drive block. You can use a PZD bit, DI feedback, or simply enable the TorqueProving function by selecting 1 from the drop-down menu. On the TorqueProving block setup page within the script, you can parameterize the minimum torque, torque ramp up time, delay time torque save, and torque reached mon time parameters. You'll also be asked to set up a Boolean input for the reset torque memory block input. During final installation of the crane, it is suggested to disable this input by setting it to 0 in the script setup as done here. However, this bit may be used during initial commissioning if the TorqueProving block fault occurs. This input will reset the last saved torque to be proven value of the TorqueProving block when it is set high. As demonstrated in a previous video, you will always be prompted to set up the actual position velocity and ramp function generator blocks. If the actual position velocity block will not be used, you can make these selections for the Enable Act Pause Vel and Start Homing block inputs. The setup for this block, when it is being utilized, will be covered in a future video. So for now, we will keep it disabled by making this selection. Finally, you are prompted to set up the ramp function generator block. Setup of this block is covered in video 2 of this series, so it will not be covered here. However, it is recommended that this block is set up correctly, as it is crucial to the operation of the drive running smoothly and properly ramping up and down the motor, regardless of which crane functionality is being utilized. Once the script setup has been successfully completed, you're shown a summary screen of your choices, and the TorqueProving function can now be used while controlling the drive. Like the TorqueProving block, the StartPulse block works to prevent load sag on a hoist. However, its mode of operation is different. When a drive is switched off, the brake applies the necessary holding torque for a load. When the drive is switched on and the brake is opened, the drive must apply the necessary holding torque. Since the necessary holding torque is not known to the drive when it is switched on for the first time, the load cannot be held and sags as a result. The StartPulse block detects the previous torque at the time the brake was previously applied to the load and uses this as a reference value to prevent load sag on a future hoist motion. To use the StartPulse block on a hoist in lieu of the TorqueProving block, the DCC must be opened by double-clicking on the DCC in the project tree. Within the DCC, drag and drop the StartPulse block from the LCRBT library and rename this block SP as shown. Once this is complete, the DCC must be recompiled by right-clicking on the DCC in the starter project tree and selecting Accept and Compile. The script setup can now be completed for the StartPulse block. The StartPulse block includes the following parameterizable inputs. During script setup of this block, you should configure the torque scaling factor, enable extern torque value, and torque ramp-up time inputs. Generally, it is suggested to use default values for these parameters during initial crane commissioning and then return to tweak these parameters later to optimize StartPulse functionality. Unless you'll be setting up an external torque value source, the Enable Extern Torque Value input can be set to 0. Once these parameters are set up within the script, complete the rest of the script as previously described and test the StartPulse block. The Simplified Load Dependent Field Weakening, or SLDFW block, calculates the load and enables the permissible field weakening speed. The load is calculated during constant travel and not during acceleration. Here are the parameterizable inputs for the SLDFW block. Prior to using SLDFW, the actual position velocity, or APV block, must be enabled and a maximum velocity in must be parameterized as follows. Calculate the value for maximum velocity in and insert this value in millimeters per second for the APV block input. The application note available from the SIMOCRANE Basic Technology V5.0 operating instructions describes how to accurately calculate this value. For convenience, the formula for calculating this value is shown here. You might have to adjust this value after initial commissioning to get the most precise drive operation possible. However, the initially calculated value should be very close to the actual maximum velocity of the drive in millimeters per second. The rest of the APV block will be covered in a future section. However, it is required to correctly parameterize these values of the APV block when running SLDFW. During script setup of the SLDFW block, you should start by setting up the Boolean input that enables the SLDFW block at enable field weak within the SLDFW block. You can use a PZD bit, DI feedback, or simply enable the SLDFW function by selecting one from the drop-down menu. You must also set up the reset load memory block input. During final installation of the crane, it is suggested to disable this input by setting it to 0 in the script setup. However, this bit may be used during initial commissioning or between crane operating periods if it is necessary to reset the torque value saved in the load memory of the SLDFW block. The remaining parameters of the SLDFW block have default values already inserted, and these are typically suggested for use upon initial commissioning of the crane. However, you can modify these inputs as desired during script setup. The final input you should take care to set up is the pass speed in to out block input. This input allows you to quickly pass a speed set point through the SLDFW block without manipulation, effectively allowing for quick digital input or PZD bit control that bypasses the SLDFW block when desired. If the SLDFW block should always be effective, select 0 from the drop-down menu. Once these parameters are set up within the script, you can complete the rest of the script as previously described and test the SLDFW block. Now you're ready to utilize the hoist-specific crane function blocks included in SIMOCRANE BT V5.0. If you'd like more information on SIMOCRANE BT V5.0, a good place to start is usa.siemens.com/cranes. In our next segment, we will look in deeper detail at the positioning features of the BT V5.0 software. Please use the link in the description below